A map is a collection of key pair values. No entries can have the same key, and when you want to look up an entry, you just need to know the key for a quick lookup. Rust gives us two types of maps, hash map and a B-tree map, also known as a binary tree map. These two maps are very similar. The key difference is how the two maps keep entries arranged for their lookup. Hash maps are stored in a single heap-allocated table, whereas B-tree maps are stored in a tree-like structure growing from the top down into many leaves, also called nodes. I don't want to get too into the data structure setup behind these, but I do want to point out that I eventually plan to add a data structures section to this course to where we can see how data structures are set up and then also improve in our Rust skills. But again, these two maps have very similar methods, so I am only going to create and use a hash map, but it is similar to a B-tree map. So the first thing we need to do is bring a hash map into our scope, and it's going to be in standard collections hash map, as was the binary heap. And now we can create a mutable hash map using hash map new. So like a binary heap did, we have the len method for length and the isEmpty method as well, which is, remember, going to return a boolean on if there are values or not in there. So let's add a couple of values using the insert method, which, as you can see, it's going to accept two parameters, the key and the value, designated by K and V. And so we can both see that they are generic types. So let's add in a key of 1 and then also a value of 1. So then we can add a couple more in, and we'll say insert 5 and 2, and then we'll say insert and we'll give a key of 30 and a value of 3. So now let's print out our hash map just to kind of see how it is structured. Cargo run, and we can see that we have 1 to 1, so key 1 value 1, key 5 value 2, and then key 30 value 3. So now earlier I mentioned that you cannot have multiple values mapped to a key. So what happens if I say at key 30 I want you to have the value 4? Because we can see that the IDE does not give us any error codes, so it looks valid. Well, what's actually going to happen here is the key is going to update the old value of 3 to the new value of 4. It's also going to return the old value. So we can actually say let old equals and then to the insert. So now if we come down here and we try to print this out, and we'll say we want to print out the old value, and now if we run this, we see that the key of 30 updated to our new value of 4, and then we got the old variable was assigned sum 3. So it's also going to return an option of type T. So great. So we're able to actually update values using the insert. That way we don't generate any bugs trying to insert a value at a key that already exists. So we can check to see if a key exists using the contains key method, and that looks like this, and we can see that it is looking for a reference to a key value. So in this case we'll say a reference to 5, and if we run this we would expect true to be printed out. which is what we got. So if we reference a key that does not exist, such as 8, false is returned. So that's great. So now we can check to see if keys exist inside of our hash map. But how about getting values back? So we can say print, and then we want to print out the value of the key, and we'll say key 5 again. So when we run this, we expect 2 to be returned, and we get sum 2. So we are returned an option of type T. So that that means that if that key does not exist, then none would be returned. Otherwise, we are going to return sum T if that key does exist. So now we have two ways that we can remove values. The first way is remove, and we're going to pass in the key that we want removed. So in this case, we'll pass in the key of 1, and if we now print out our, and I'm just going to copy this, if we now print out our hash map, we expect the 1 to 1 to be gone, which, as you can see, so it's up here when we create it, and now down here our key of 1 and value 1 is gone. But this also returns the value for us. So if we run it this way, then we see we get sum 1 returned. So it does return a value if we decide to do it that way. Now another way we can do it is we can say remove entry. So we also get a returned value from this, but it is a returned pair value. So remove entry is going to actually return the key and the value. So let's remove the key of 5 and make sure that the key of 5 is returned as well as the value. So we can see that we are returned the key of 5 and the value of 2, which is what we initially inserted in. So the difference between remove entry and remove is that remove entry is also going to return the key alongside the value, whereas remove is only going to return the value. And then if we quickly want to clear out our hash map, we can use clear, and then to verify that this was cleared out, we can use our method isEmpty. And since we ran clear, we would expect this to return true, which is what we got. So these are just some of the methods associated with the hash map. Again, a B-tree map and a hash map are extremely similar, so I encourage you to create a B-tree map and then just basically do what we did here, just to make sure everything works the same and that you are also familiar with how a B-tree map works.